How do you design a building that's earthquake resistant, especially in the Bay Area of California? Well, let's find out from an actual structural engineer who designed the Grimes Engineering Center in Berkeley.
We know this building's going to go through a large earthquake. We're near the Hayward Fault. So there's two systems working to resist earthquake forces. On the interior are buckling restrained braces, and that's a traditional way of resisting earthquakes. Many buildings struggle with leaning after an earthquake, and this is problematic for stairs and elevators, and it's problematic for getting people back into buildings. To make sure the building isn't leaning after an earthquake, there's a series of tension rods around the perimeter of the building, and those tension rods have a shape memory alloy device. And shape memory alloy is a remarkable material. It's been around since the 60s, and it's the combination of metals or even plastics that have some remarkable properties. And what they will do is, as they deform, they will bounce back. So it's a metal, but it behaves almost like a rubber band. And that helps pull the building back during and after an earthquake to help ensure that it's going to be centered after the earthquake.
Tell me a little bit more from your perspective as a structural engineer here in the Bay Area. What other measures are needed to make it earthquake resistant?
So designing for earthquakes in the Bay Area, we often figure out the lateral system at the same time we figure out the gravity system. So it's one of the first things that we decide in a project. And on this one, where we're resting